Let's take a look at the solutions to the token state exercises. If you haven't done these yet, just jump back to the last video and have a go at trying to implement token state. So we're going to open up our state tests here, and we also have our token state definition here. And so if you remember, we're trying to implement token state in such a way as that it meets the design we laid out and passes the state tests. So if we look at the first test here, we're checking that the token state has an issuer, an owner, and an amount constructor parameter of the right type, where Alice here is of type party, Bob is of type party, and 1 is of type int. So what we want to do is define a constructor for our token state that takes these parameters. So I'll just start defining that here. So public token state, and here I'd have owner of type party. So writing the Kotlin style there. So party owner, party issuer, and int amount. So the ordering here of the fields might be important. And so in this case, I want the issuer first, then the owner. So let me just switch those around. There we go. And here I'm going to want to assign these to fields. So here I'll say this.issuer equals issuer, this.owner equals owner, and this.amount equals amount. Then I'll create private backing fields for these here. So private issuer, private party issuer, private party owner, and private int amount. There we go. So that should now pass the first test. So what we've effectively done here is defined a constructor for our token state. There you go. The next step is to provide a getter for the issuer, the owner, and the amount. So here we're taking a token state, we're creating a new one, and then we're calling getIssuer and checking that the issuer is equal to Alice, as in the constructor, the owner is equal to Bob, as in the constructor, and the amount is equal to 1, as in the constructor. So let me just add these here. So I'm going to do alt enter, create getter, and create getter for amount. And there we go. So we now have a getter for the issuer, the owner, the amount. And if I go back to my tests, I should be able to run these as well. And there we go. So the next test is to check that token state implements contract state, the interface. So we're checking here the token state is an instance of a contract state. And this is really important, right? Because remember that we said that in the Corda platform, for something to represent a state, it must be an instance of a class that implements contract state. So no matter what we do with token state, unless we implement this contract state interface, it's not going to be a state. So let's add that now. And very straightforwardly, here we want to implement contract state. This will start complaining because if you remember, contract state has a field that we need to provide, which is a method, get participants. But here we can just auto generate that here for now and just return null. And that should pass this test. So although our participants field isn't very well written, we have implemented contract state. And then the last step is to give our token state two participants, the issuer and the owner. And this is very straightforward. So here I could say list abstract party participants, new array list perhaps, participants.add issuer, participants.add owner, and return participants here. And if I go back to my tests, this should also now pass. So here I'm making the issuer and the owner participants, which effectively means that they'll be notified of any changes to the token state. And now I can just run all these tests at once and check that it's gone well. So yeah, so we now have our token state implemented. So you can see here, it's a class that implements the contract state interface, has 3 fields, 3 pieces of information it will represent on the ledger, the issuer, the owner, and the amount. There's a constructor token state which takes these fields. So when we create instances of our token state, we'll be providing this information. And we'll see how we do that in flows. And then we have getters to get these fields back so we can consult the state on the ledger. And finally, we have this list of participants, parties who will be notified of changes. In summary, we've seen how shared facts in Corda are only distributed on a need-to-know basis. This is a key strategic and legal requirement for many business blockchain applications. And we represent these shared facts as states, which are instances of classes implementing the contract state interface. And when we looked to this contract state interface, we found that it requires you to define a participants field, which is a list of the parties on the network who are going to be notified of changes to this state over time. And also we need to add additional fields to our state to capture the information that it's supposed to represent. So that's the end of this section. Come back in the next section where we'll start looking at contracts on Corda.